Hey everyone, and welcome. Look, if you've ever fired off a query and then had enough time to, I don't know, go make a whole pot of coffee before it finished, you are definitely in the right place. Today, we're going to put on our detective hats and solve one of the biggest mysteries in the data world, the case of the incredibly slow query. This is it, right? This is the question that keeps us up at night. You've written what seems like a perfectly good SQL statement, but the database just sits there, spinning and spinning. So, what is actually going on inside? Let's find out. For most of us, we just send our instructions into this black box and, eventually an answer pops out. But the whole how and why of the time it takes, it's a complete mystery. So, our job today is to crack that box wide open and take a look at the machinery inside. Let's get started with the very first step the database takes. Okay, so before a single byte of data is even read from disk, the database does something pretty amazing. It thinks. It actually creates a plan, a kind of blueprint for how it's going to tackle your request. And this is our very first piece of evidence. And it comes from this really clever part of the database called the query optimizer. And that phrase right there, best guess, is so important. The optimizer is like a master strategist, right? But it's only working with the intelligence it has on hand, which are its internal statistics about your data. So this plan isn't the absolute truth of what's going to happen, but it is the intended strategy. So how do we get our hands on this blueprint? Well, our first tool in the detective kit is the explain command. It's super simple. You just stick the word explain right in front of your select query, and boom, the database shows you its secret plan without actually running the whole thing. It's kind of like getting the director's notes before the movie is even shot. And this right here perfectly illustrates the heart of our whole investigation. So that blue line, that's the optimizer's estimated cost for a bunch of different plans it could use. But the red line, that's the actual runtime. See that gap? The optimizer doesn't always pick the plan that ends up being the fastest. That gap, that's our mystery. That's our first huge clue that the plan and reality are not the same thing. Any good detective will tell you, never take a plan at face value. You've got to compare the blueprint to the actual scene of the crime, the theory to the facts. So let's grab our next tool and see what really happened when the query ran. This really breaks it down perfectly. Explain is the plan, right? It's the intended strategy before the race even starts. Profile, though, that's like the post-race analysis. You run your query with the profile command, and it captures what actually went down, every CPU cycle, every byte of memory used. It gives us the cold, hard facts that we need to compare against the plan. Now, to really get where things can go wrong, we need a quick look under the hood. In a modern distributed database, you have one initiator node that acts like the lead detective. It gets the query, it makes the plan. Then, it hands out pieces of that plan to a bunch of executor nodes to do the work in parallel. And this is what makes these databases so incredibly fast. But it also creates all these new places for things to go wrong. If just one executor node is struggling, or if a ton of data has to get shuffled between them, the whole query can just grind to a halt. And that's often where the bottlenecks are hiding. All right, we've got our tools, explain and profile, and we understand the scene of the crime, so now it's time to line up the usual suspects, the most common culprits behind a slow query. Our first suspect, and honestly, often the most dangerous one, is unnecessary network traffic. Think of it like this. A local join, that's the ideal. It's like a quiet conversation happening in the same room. A resegment is like having to run across town just to talk to someone. It's costly. And a broadcast? Oh man, that's like mailing a physical copy of the phone book to every single person in the city, just so they can look up one number. For large tables, it is an absolute disaster. Next up on our list is the join strategy itself. A hash join is usually your workhorse. It's fast, it's effective. A merge join can be lightning fast, but only if the data is already sorted in just the right way. But if you see a nested loop join in your plan, that is a major red flag. It's the database equivalent of checking every single item against every other single item, one by one. It almost never scales well and usually means something is very wrong. Now for a suspect that's a little sneakier but just as deadly to your performance. Memory spills. See, the database tries to do as much work as possible in super fast memory, in RAM. But when an operation, like a big join or a group by, runs out of that memory, it has to spill the extra data to the much slower disk. This is a total performance disaster. It's like a 6-lane highway suddenly being rerouted through a tiny village side street. Everything just stops. So, we've got our clues from Profile, and we have our list of suspects. Now it is time for the final act, connecting the evidence to the culprit and finally solving this case. This, right here, is what we're looking for. This is the smoking gun in almost every performance investigation. You run Explain, and the optimizer tells you, yeah, I think I'm going to process about 10 rows. Then you run Profile and see it actually process 10 million rows. That massive gap between the estimate and reality is the single most important clue you can possibly find. It tells you the optimizer was basically flying blind. So, why was the optimizer flying blind? Well, because of this, stale statistics. The database keeps these internal notes about your data, how many rows are in a table, the distribution of values, things like that. But if you've loaded a bunch of new data or changed things around, these notes can get really outdated. And so the optimizer is making its best guess based on old, totally wrong information, and that leads to these terrible, terrible plans. And this table puts it all together for us. Think of it as your detective's handbook for cracking the case. You see a bad join choice because of huge estimate errors? The fix is to update those statistics. You spot a plan that's broadcasting a giant table all over the network? The fix is to rewrite that query to get a nice local join. You find a spill event in your profile? Well, the fix is to either give the query more memory or figure out a way to make it less memory hungry. It's all about matching that clue to the right fix. And that really is the key takeaway here. You don't have to treat your database like a black box anymore. By understanding how to use Explain and Profile, you can read the clues, you can identify the suspects, and you can become the detective who solves your own performance mysteries. Because ultimately, every query plan, every profile, is the database communicating with you. It's telling you exactly what it's doing and where it's struggling. The only question is, now that you know the language, are you ready to listen? The clues are all there, just waiting for a good detective to find them.